All right, so we've pretty much covered all the material, and so we're in review mode. And I thought of something I wanted to talk about. But let me start by asking all of you, what do you want to cover right now? Yeah.
Yes, I have a question about the tic-tac-toe.
Yeah.
Again, when the user puts, they choose a spot, it has to be like the box, right? Like if it's like we have 9 boxes.
Yeah.
Let's say they want to put it first in the center.
Yeah.
It has to go right there, right? It's not like the
It's
Connect
not.
Four.
It's not like Connect Four, no. So in the tic-tac-toe, it'll look something like this. First, you print the board, right?
Oh, that's
so,
beautiful.
So maybe the board would look like that. And, so you could you could print this. The other thing you could do is you could put numbers in here. Like this could be 1. And I've seen students do this. 2, 3, like that.
How do you print the lines though with the numbers? Like I got the number part.
Yeah.
But do you have to do a separate table with like C out?
Let me show you that. Yeah. It's a separate output command. So you would do this. Let's suppose you had a number. Let's suppose you had a char array.
So we don't even use a 2-dimensional array?
You can. It's up to you how you want to do it. It's up to you how you want to do it. See how I'm doing this? Well, that's an example of one line. Well, there's nothing in 3.
Okay.
No, it's sort of work it like that. This is 0, 1. There's nothing in 3. What would this top line look like? Something like this, right?
But you're doing in the main function. Is there a way to do it in like the table formula? So you just do print table and then it prints it each time?
Well, you can do it that way. But you could do it that way. Like putting the special characters, like putting this inside of a table, like that.
Like
If you wanted to put these formatting characters, The only thing I'm putting in the table are the values that are going to change. Like here, when the player makes a move, let me finish this here. So here, the player takes a move, and then we're going to print the table again. Now, normally you do this in a loop, you would use functions, and I'm just showing you. Let's suppose the player moves in position 2. So the player enters in like the value 2. And, let's suppose that the entered, we'll call it the cell number. And if the player enters in 2, right, because that's what they see. We're showing 1, 2, 3, 4, 5, 6, 7, 8, 9. So the user can enter in a number. Then we read the number, and then, of course, we're going to need to decrement it to go zero-based. And then inside that cell, we put an X. And then we print the grid again. Oh, that didn't quite work there. Get rid of that. Get rid of that. Add some spaces so we can see better. See here we print the table with the numbers appearing in it, so the user knows how to pick a cell. When the player then takes a move, maybe the player presses the number 2, right, enters 2. Now an X appears in that cell. And of course the computer needs to move, so an O will also appear in a different cell. And then we prompt the user for another move. You enter in another number. Is that okay? That's how some students have done it in the past. You can also use a two-dimensional array. I'm just showing you one possible solution. This is the one that I think is the easiest. But the other solutions may be easier for you because that's how your thinking goes. So use an alternative approach in that case. Well, the only information that I'm putting in the grid, in the array, is just the data that changes. These little symbols here that don't change, we don't need to have those recorded in our data structure. They're just part of the print function when we print this thing. Yeah.
So we could put the numbers in the cells, right?
Yeah.
So they don't have
And then when the user enters a value, you just cover it up. You replace it with, this character. I've also seen another approach that students have done, and all different approaches are fine. Another approach is that you put the numbers in here, and you just print this each time. Just to make it a little nicer. See that? So you print that, and then 3, 4, 8, 11. And then the user takes them, and then you print that, and also print a blank grid underneath it. So each iteration of the loop, you print the grid with the numbers in it, and then you print a blank grid. And then the user takes a move, or the user enters, say, 2, and the computer picks 6, and then what do we print? Let's see, 24, 26. And then we just, after that data input happens, we print the same information at the top. That doesn't change. It's the same array of numbers in the grid. So we're just repeating that information to the user so they see it. But now instead of having a blank grid here, we see an X there and an O here, because that's what the user and the computer chose. And then we continue that process. So this is another way to do it. So you're not, the way I showed you here is where you only have one grid each iteration of the loop. One grid is printed with numbers in it, and the numbers are progressively replaced by X's and O's. And that's one approach. The other approach is this sort of information grid here that shows where the moves go. That never changes. We just always print that at each iteration of the loop. And we've got this other grid that shows the moves in it, which is initially empty, and then it fills in progressively as user picks moves and the computer plays. And then the grid itself, this is a one-dimensional way to do it. You could also use a two-dimensional way. So it could be 3 by 3. Is one way to do it. So we could have done the grid like that, see? And then this would be A0, 0, A0, 1, A0, 2. It's another way to do it. And when the player makes a move, it's we could ask either for a number or for a row and a column. Usually what the student will do at this point is ask for a row and a column. So row 2 and say column 1. We decrement the row, decrement the column, and then the row column gets the X. So we could do it like that. You know what, let me do it like, let's see it work. Let's see if that works. Yeah, see? So the user would enter a row and a column. So you prompt the user for a row and a column. So there's lots of ways of doing it, and you pick the way that makes sense to you, or the way that you think is the easiest or or best, and then try that. And I want to emphasize too that the main learning that I believe should happen on this problem is to understand that incremental development. You can't code up the whole solution, compile it, and have it run. I mean, I can't do that, right? Maybe I could, but because I've done this problem many times. But for you, it's inconceivable to me that you could be able to type up the entire solution without compiling it, testing it, running it at any intermediate step of development, and have a finished running program at the end. I can't see that. It seems so difficult and improbable that you would actually complete that process. You do it, and I'm showing a way that I believe is the most useful to you, and the fastest way to solve the problem. The very first thing you do, you write a program that says hi. That's it. Then you write a program that prints maybe an empty grid. And then maybe you add a loop and you have the user type in a number, and after every time the user types in a number, you print the grid. Maybe the grid doesn't change. You're building the program one tiny step at a time. Now, each step has a very small amount of development in it, but it runs. It compiles and it runs in the way that you can predict. And then each step, then you go step by step and converge to a solution. I can't see any other way to do it from your way. I mean, there are other ways. You could try to type the whole thing. Here's what a lot of students do, which I strongly advise against. Take my Connect 4 code, copy it, get it to run, and then start modifying it to turn it into the tic-tac-toe problem. I strongly advise against that. You're not going to learn much from that. You'll learn a little bit. You'll learn how to take something that's close to a solution and modify it and put it into, make it do what you want. I guess that's useful. Yeah, so I would say that's useful, but it's not what I intended from my, but that's your choice how you want to approach the problem. You can decide to do it any way you like. But I think the incremental process of development is very practical and widely used. Because the other approach is also widely used. Take something that's as close as possible to what you want and modify it. That's also used in practice as an approach. Yeah. Maybe it's just my preference, and I don't like that approach. I like building things from the very beginning all the way up to the end. Within reason. I mean, normally, if you're coding and you're writing programs, like say you're making a video game, you're not going to code every piece. So you're going to use libraries. You're going to use big chunks of already written code that have very clear interfaces and drop them into your project. And then you'll use those, like a physics engine, for instance, or a graphic system, or a portability layer, so that the code you write runs on, Mac and Windows, or Mac and Windows and mobile phones, something like that. Or another possible library that you could drop into, say, a video game project would be a sound library, so you don't have to interface directly with the operating system's API for rendering sound. Let's use a platform-independent library. Let's use a library that provides a platform-independent API, or application programming interface. So the code you write in C++, C++ is portable. You can write code that will compile and run on Mac and Windows and Linux and iOS and even Android. It's harder to get it working the way you want on Android, but because it's more Java based. So yeah, you learn what you want out of it, I guess. You want to take my code and modify it. That's one approach. But I don't. I just. I don't think that's the best way to go about doing it. Any other questions?
So for the tic-tac-toe, the AI doesn't have to be very intelligent.
No, yeah, because what I was thinking is, I mean, if you want to have the basic AI is to call rand. Let's suppose you have an array that's just 9 elements. So you mod 9, and that's your that's the computer move. And you know, if it's a bad move, then you know, continue the loop, something like that. So just loop forever. Else, if it's a good move, then you know, make the move. Make the move, and then break from the loop. Yeah, you probably can do a better job than that. You know, somehow making this. You know, you could use a do while loop. I mean, maybe that's easier. So do. You know, make a move, and if it's a good move, now maybe do while doesn't work actually. So if it's a good move, then make the move and break. It's another infinite loop. And I'm just typing it out here like pseudocode. See, it's not valid stuff. So maybe this this is like loop forever. They're essentially the same thing. Here I'm just checking for bad move and doing continue. And it's better to remove continue. You know, I don't think continue is great to have in there. So this is slightly better, I believe, as a loop. So because you only want to enter that loop if there's at least one free cell. So you want to check a tie first, you know. So if you know, if there's no tie, you know, then do the following. Otherwise, if there is a tie, if there's a tie, then you know, display tie and quit. So that when you hit this loop here, you know that there's at least one available slot. Because remember, tie checks to see that every spot has been played. If you're using rows and columns, then you're not going to want to do this. You'll do something like, you know, maybe you'll do a random row and a random column. And the function, it'll take row and column this time, the good move function, if you have such a thing. I mean, good move is pretty simple. It just, you know, good move would be like this. It would be, say, row, column, return, what is it, A of row, column, not equal to X, and A row column is not equal to Y. There's a good move function right there, using rows and columns. You know, so you could have the function in there, or you could just say, I don't want a function. That's not readable to me. I'm going to put it right inside the if statement. I'm going to get rid of the if statement, and if this, you know, then do this. But that's hard to read, right? So it's easier to read if you say if it's a good move. It's easier to read the function that says good move, right, rather than having that condition in there. It's a little more readable, I believe, to use the function called good move. Otherwise, you might need to add a comment here. Maybe the comment would go up here. So if row column is a good move, then make it an exit loop, you know, something like that. But you wouldn't need to put a comment in there if you used the function. If you used the, you know, if you did it like this, if good move, row column, like then you don't need a, that's so readable that you don't need a comment anymore. See, if you stick this condition in there, then it's, oh, well, it takes time to read that. I mean, you can figure it out. But, you know, 3 months from now, when I go back and look at the code again, and that happens all the time, I've got to remember what that means. And so that takes time and energy. So, but if I go back 3 months later and I read good move, row column, well, I don't even have to think about it. The name of the function tells the whole story. So that's readability issues. You know, it's, you decide. You like these two lines, that line and this line, you know, or do you like just that one line there? Not only that, but this one line actually is it's not quite that simple. This one line is also requires a function. So that's the negative part of it, is that you also need to provide this function. So more functions in your file makes the file a little harder to read and manage. But I still think that this second solution is better. Because I can, if I see a function that says good move, I can just skip over it and say, oh yeah, that just tests whether the move is good or not. I don't have to look at the detail again. It's easier for me to just read good move than it is to parse this statement and figure out, oh, I see, if there's no X there and there's no Y there, that means that hasn't been played yet. So, I mean, it's not that hard to parse it. So you might want to go like this. If you like it like this, and you want to reduce the number of functions you have in your program, you can go with this solution. Now that's a judgment. That's your judgment. You're the one that's programming it. You're the one that's going to maintain it. Well, maybe you're not the one that's going to maintain it. Maybe that's the intern that's going to maintain it. You're just going to write it and then get the intern to maintain it later on when the boss wants a change or the client wants a change. Remember to go for frequent compilations and runs. Don't do too much all at once. Don't do a lot. Do it just a little bit and make sure that it runs correctly. And then keep building one layer at a time, one step at a time. I'm glad everybody brought your laptops and you're working on the problem. That's great. That's the way to do it. Yeah. That's the way to do it.
So I have my, it's from the project. I have my grid done.
Yeah.
When I print out the numbers, I wanted to start with 1 on top, 1, 2, 3,
Yeah.
and then 4, but they start in the bottom, 1, 2, 3, and it goes, it's 5 gigs. So the one starts.
So you're the one is on the bottom row?
Yeah. So I'm getting it to print my X where I want, but that's not my grade up here.
Let me see the loop. Just get something backwards, that's all. You're starting at row 2, you're going to row 0. I started at row 0, went to row 2. You're looking at the Connect 4 code, see? That's the problem. You're coding from Connect 4, huh?
Doesn't it start at 2?
Well, it depends. I mean, I'm calling this, sorry.
That's
What the heck's going on here? Edit EX mode, type visual to go to normal mode. It never happened to me. Okay. Yeah, this to me is row 0. And this is row 1. And this is row 2. So you did it backwards. You're rendering row 2 first. Then you're rendering row 1. Then you're rendering row 0. So that's why it's coming out upside down. And that came from the Connect 4, didn't it? So that's a different problem. They're only a little bit alike. So they're different problems. They both use arrays. You know, they both have a console interface. They both have a loop where the user enters something and the computer makes a random move. Oh yeah, if you wanted to do more AI, I mean the simplest AI beyond choosing a random position would be to check to see if the middle square is available. If it is, take that. So one easy move to do. Or if you want to go beyond that, then you can do a little more. You can check you could try each possible move and see if you have a win. You know, if I go in, you could put the value, your O, in each available slot and call, do I win? Does the computer win? And if you get a yes, then you play there and the computer wins. You can do that. That would be great. Make it more fun. And then there's approaches, there's complete solution where the computer will always do as best as possible, using an algorithm. I'm not going to get into because I don't use it very much in a long time. And I can't remember the name of it. Something like max-min, something like that. It's the same algorithm you use to play chess. And although with tic-tac-toe, you can exhaustively search all possible moves and make a perfect move in your AI. So the computer will never play poorly, which you can never win the game, whether you go first or second. And, but with chess, the computer cannot exhaustively search the entire possibilities. It can only go to a certain depth. It can only probe a certain number of moves forward and pick a good move based on that probe. So sometimes, players can beat computers because players have a different approach when they play, right? I hear they memorize patterns and they recognize, they use pattern recognition to see familiar circumstances where certain strategies work out better than others. The computer, at least the chess playing programs that I'm aware of, don't do that. Maybe some of them do. I don't know. I don't study that area. The AI is a great area to get into. Like how to make the computer play so that it makes the best move. Because that does not make a fun game. That's like, imagine playing a game where you're playing against AI, and the AI is so perfect you'll never win, right? So it's not about having fun. It's about generating an optimal solution. And so like game AI is different than AI that's used, say, a military AI. In military AI, you absolutely want to win, right? In the game AI, you want the game to be fun, so you got to let the player win. So you don't want the AI to just win. Yeah.
I have a question. When I started doing my code, I put since I used the 2-dimensional array.
Yeah.
I put it under the main, but then I did my loop in the main. But now that I'm trying to make a function for the user move, I have my 2-dimensional array declared in the bottom, like in the main.
Yeah.
And then, but when I put it like above the main, it doesn't let me. It's weird.
Let me see it.
Like, so I had this code from the bottom. So that was for my move, and I have the position of the grids.
Yeah, that's okay.
Because the way I did it was I let the user enter number, and then depending on what number it is, it will go on the position. But if I
See, now you're putting numbers in the grid positions and you're putting characters. These should be characters probably. You should put apostrophes around the 1, apostrophes around the 2, so it's the same as apostrophes around the X. So you're storing character data. You're storing integers in there.
because
it's
I'm
an int.
comparing.
Oh, that's grid position in. Oh, okay.
I'm comparing the
number
they put.
Yeah.
So I compare what they put.
Oh, yeah. You can do that. Yeah.
So that's why the P equals.
Yeah. So your data is stored in a 2-dimensional grid.
Yeah. So where would I put the 2-dimensional?
So don't you want to go? So the player will enter in a 1, and you want to go to 0, 0, right?
Mm-hmm. So I'm saying this in order.
So this isn't going to work.
It works when this is down here.
Yeah.
But if I want to initialize this grid, do I do it up here? Under this one?
Yeah, that's a good place.
But
Oh, I see. You mean this is used elsewhere, right?
yeah, so this is a different.
No, you can initialize it here, but declare it only with the declaration.
Oh, this one?
Yeah.
And I would use a different.
And then init, when main runs, when main runs, it'll initialize the grid.
So I could keep the values under.
Yeah, that's initialization. What you just said, values. That's your initialization code. See, main is where things first start running.
All right, it works.
It's good.
Yeah.
All right.